my name is Hamad. I'm here to explain the techniques used to load the main memory blocks into the cache. There are actually three direct, associative, and set associative mapping techniques that are used to load the main memory blocks into the cache. First of which, there is direct mapping. This is the simplest technique, and each single block from the main memory is loaded into only one cache line. The mapping is expressed in a function where if you have the main memory block number and the number of cache lines, you can get the cache line number where the block is going to be placed by getting the mode of the main memory block number and the number of lines in the cache. In this mapping technique, the first m blocks from the main memory feed up the first m lines in the cache. That is from L0 to Lm-1. The next blocks of the main memory map to the cache in the same fashion. That is, if you have block Bm, it maps to L0, and then Bm plus 1 maps to L1, and then Bm plus 2 maps to L2, as shown in the diagram. This maps to this. When you reach to this point, the next block would map to the first line, and so on and so on. There is also set associative mapping and associative mapping. And in associative mapping, this overcomes the disadvantages of direct mapping. The disadvantage actually of direct mapping, since in direct mapping there is only one way in order to place a block from a main memory. But in associative mapping, the block can be loaded in any cache line, as you can see. If you have a block, it can be loaded in any of the cache lines available, and the block and the address portion of the cache is split into two: the tag and the word section. So if the control logic checks and the block matches a given tag, it is placed there. There is set associative mapping. This technique exhibits the strength of both direct and associative mapping. In this case, the cache consists of a number of sets, in each of which consists the number of lines. So set associative mapping can be split in a given number of ways. You can have k set associative mapping, where k can be any integer. It can be 2, it can be 4, and so on. So when you have a given number of sets and you have the main memory block number, you can get the cache set where that block is to be filled by getting the mode of the main memory block number and the set number. So when you get the mode, that set you get, the control logic checks, the control logic checks, and then can place a given block in a given set. So a block that has a tag matching to a given set can be placed in any of the lines in that given set. That is actually the implementation of set associative mapping and associative mapping. Second on, since when we're bringing in blocks from the main memory, a situation can arise when the cache is full, and so there is need for an algorithm that can replace the blocks in the cache. The most commonly used replacement algorithms, the techniques that are used to actually replace the blocks in the cache, they include the least recently used, the first in first out, and the least frequently used. In the least recently used algorithm, the block in the set number that has been in the cache the longest without reference to it is replaced. So if you have a block in the cache that has taken long without being referenced to, it is when a new block comes in, it is the one that is replaced. Actually, this is the most efficient replacement algorithm, and it is because of actually its simplicity in implementation. The first in, first out is another kind of algorithm, and in this algorithm, the blocks are evicted from the cache in their order of arrival. I.e., if you have a block n that came in before the block m, so when a new block comes in, block n will be replaced in that queue, like the one that came first is replaced. Yeah. So there is also another replacement technique called the least frequently used. So in this algorithm, the block that has experienced fewer reference is replaced. If you have a block n that is there, that has been there, and the number of time it has been referenced to less, when a new block comes in, it is the one that is replaced. Thank you. My name is Herman Katende, Computer Science Makerere.